All right, let's dive right into this explainer. We've tailored this one specifically for you, the corporate energy buyers, plant managers, and heavy industry strategists out there who are currently trying to navigate the incredibly complex world of behind-the-meter battery storage. Look, if you're focusing on industrial decarbonization, hedging against wild energy market volatility, or really just upgrading your overall energy management strategy, I'm betting you've had a battery energy storage system, or BESS, pitched to you pretty recently. On the surface, it looks like a highly lucrative, totally straightforward win, but as we're about to see, the physical and legal reality of actually integrating these massive systems into medium-voltage grids is anything but simple.
Just let this quote sink in for a second. Savings often evaporate before the containers are even energized. Wow, that really captures the harsh reality of utility-scale BESS projects, doesn't it? And it sets the stage perfectly for why we absolutely need to look closer at the hidden pitfalls of grid integration. It is so easy to get completely swept up in the projected financial returns and the sleek, modular look of those shiny battery containers arriving on site. But the truth is, the friction introduced by the actual integration process can literally drain your entire project budget before you even get to flip the switch. We're going to unpack exactly why this happens, and more importantly, how you can stop it from happening to your operation.
Section 1. The Silver Bullet Myth. So, behind-the-meter storage is almost always pitched to heavy industry as this ultimate glowing silver bullet. And let's be real, the promise is incredibly alluring, especially with today's intense energy cost inflation. The pitch is simple. Just drop these battery containers on your site and boom, you seamlessly bypass those soaring grid tariffs that are just eating away at your OPEX. Better yet, you can finally beat those brutal peak demand charges by discharging the battery during peak pricing hours, effectively shielding your operating margins. It sounds like the perfect frictionless solution to all your energy woes, right? But is it actually that easy?
Well, this comparison brilliantly illustrates the massive contrast between expectation and reality. On one side, you've got these glossy feasibility studies where everything looks fantastic in the boardroom. Those early spreadsheets focus entirely on the theoretical savings, charting out exactly how you'll bypass tariffs in a perfect frictionless vacuum. But on the other side, you have the medium voltage reality. You are immediately hit with the heavy drag of strict internal grid codes, incredibly complex accounting rules, and these rigorous safety interlocks required by your grid operator. This massive gap between boardroom projections and the physical, regulatory reality on the ground, that is exactly where most of these projects stumble.
Moving on to Section 2. When reality hits hard.
Here is the crucial takeaway. Moving past those initial feasibility studies and actually attempting to integrate high-capacity battery energy storage into your legacy medium-voltage industrial grid is a massive wake-up call. It completely changes the entire equation. You aren't just dealing with a standalone battery that acts like a giant smartphone charger. You're dealing with a massive dynamic power source being grafted onto an older, highly regulated internal grid that was honestly never designed to handle bidirectional power flows. And that fundamental mismatch, it triggers an absolute cascade of necessary upgrades and compliance checks.
Okay, before we go any further, we absolutely have to talk about a critical hurdle, balancing group accounting, or, as it's known in the European energy market, Bilanzkreis. I know, it's a bit of a mouthful, but you need to understand that this is not just basic corporate bookkeeping. This is the intensely complex requirement of tracking, matching, and reconciling electricity supply and demand on a highly granular level. We're talking down to 15-minute increments. It's absolutely mandatory for internal grid compliance and stability. Managing this accounting adds immense and often completely unforeseen administrative complexity to tracking your internal power flows once a massive battery is introduced into your ecosystem.
Which brings us to Section 3, the regulatory minefield. When we break down this chaos, you're essentially staring down a three-headed monster of grid integration that stands directly in the way of your ROI. First up is the regulatory head. You have to navigate strict utility unbundling rules, meaning you must legally separate generation, storage, and consumption, all while adhering to rigid internal grid codes. Second is the technical head. This is the physical reality of installing redundant metering and complex safety interlocks for those bidirectional power flows. And third is the accounting head, managing that complex balancing group accounting we just talked about, all while carefully navigating grid tariff exemptions so you don't accidentally get hit with fees on the power you're just trying to store. This three-headed monster is exactly what drags out your timelines and inflates your capital expenditures.
So how does this actually play out on the ground? Well, local grid operators are fiercely protective of grid stability, and they're going to mandate a strict sequence of constraints. Step 1, you have to painstakingly navigate their specific local rules and interconnection agreements. Then, step 2, you're often forced to install redundant metering because the utility needs verified tamper-proof data that's totally independent of your internal systems. Finally, step 3, you must implement complex safety interlocks just to safely manage the power flows between the battery and your legacy grid to prevent any backfeeding anomalies. Every single one of these steps requires significant time, exhaustive engineering, and some very serious capital.
And because of this grueling, multi-layered process, we arrive right back at our initial revelation. The end result? Those projected business case savings, the ones that look so incredible in the glossy feasibility studies, often vanish entirely. The sheer cost of regulatory compliance, the expensive redundant hardware, and the ongoing administrative burden eat up your anticipated margins long before those battery containers are even energized. What started out as a brilliant cost-saving initiative suddenly transforms into a costly administrative and engineering headache.
Let's pivot to Section 4, Frameworks for True Profitability.
To actually survive this minefield, you've got to proactively adopt 3 strategic frameworks right out of the gate. You simply cannot treat these requirements as afterthoughts to figure out during the construction phase. From day 1 of planning, your strategy must address regulatory compliance and unbundling rules head-on. At the exact same time, you need a robust framework for technical interconnection constraints. You have to know exactly what the local utility will demand for metering and safety before you even order a single piece of equipment. And lastly, you absolutely must have an automated, stress-tested system in place for accounting and Balancekreis management. If you build these 3 strategic pillars into your initial project scope, you'll accurately forecast your true costs, protect your business case, and ensure real, lasting profitability.
So, as we wrap up this explainer, I want to leave you, the industrial strategists and plant managers out there, with a provocative question to evaluate your current decarbonization roadmap. Have you found a clean way to streamline internal medium-voltage grid integration? Or has balancing group compliance turned into your biggest project bottleneck? It is a crucial question to bring to your teams this week as you review your energy storage initiatives and map out your next steps. Thanks so much for joining me on this deep dive, and keep pushing for smarter, strategically sound energy solutions.